Skole ngambulo luku. With whatever we do. Jioni safu nola. With whatever we do. Hale yidemu new school. Nyepamne nekulukula. Nyepangiragala gena. Pamne nekulukula. Ibuloke nongoto ni beti sola. Ibuloke ndato ni betoto.
Mingi Congo.
Lamin.
Na?
Lamin te jibe norin te nyame Lamin.
Kabo na wulo kono.
Wulo kono nyinte mo Lamin.
Pabilenki.
Muna ngata afole.
Haina.
Ngata. Ngotole. Fabrama.
Mingi. Baba nyola.
No ngotole. Fabrama.
Na mu jumara kan kuma ni ten.
Fabrama.
Jumara mu.
Ndel bare muto.
Lunda mana. Jamani bere.
Alindo ko.
Jamani. Bari jamani bana na mu duma kontan.
Ngoto mina ka ngala mi je fon filita la mi jibe nori nyala.
Lamin ila siran sama ne benki. Yala so tol sayni no ko ngol ko momo.
Ngoto.
Nam.
Inte yalo ne Lamin hakilo diata bake karamu. Anu senteng ministry ko di ngole si so na manke ko do
si bitun.
Bagona ringa.
Ala na ko na karta bulo be damna ala nije.
Ngoto.
Nam.
Ngoto mon kontan feren.
Jamani mu ne keda.
Ife ka Lamin wulo ko no nyintay mon ko do fete malo Lamin nyande sila la be la moy kala karango.
Jamani karamol be sorne ne ko fasita wulo kono ko.
Karamol ma ko ni ko karamol soro nda manke comme holiday lem. Ngoto. Dini wo nyanta sila la ala karango la moy yamin kaben fue. Man kontan anda mande.
Allah nyin kombo kurang ada ndala mbolen do la jan karamol le soro ndaro kabe ko mara do la kombo. Ko fane na karamol soro nje karamol soro Lamin ada lo aman tara fe na sokon. Ala mu nekela
Lamin ite fete malon ko lesinol ke kar radio to.
Nga fine.
E ko nyani mo la.
Nga fine.
Ya mu na fonye.
Tabi mina kan tambita nteri maning fatu. Tambita to ala dinol bebe siri be la moy ka.
Fatan so am fanan tambira jele ni subala nga je dinni ngol be je talanta nen kili warol be serin jelen
sa Lamin fate ku kili wo ke no la ba Lamin bitaka wulo ko no taymo Lamin
aman dara fenna
ite dine ko ni ma ye kari sino la moy radio to ba
mo ne ka ke afonde ba ni alon
telentel jikot
afonde ba mo be ke
ite balantel be jikritel ni man karambe ku tele yaje nata karana mbasa malaka ay tarije
par ñarande kombo courant ho findira kombo ide na raje den sonka bay ko Lamin manya wulo ko karam mo so da fanya membe
ko to wole nati bayo ngalle ni Lamin kuntala kombo courant o ka fa kombo courant asototal wala kinay ko e sisu kono bari ni ko e sisu kono be kangol dike la radio lin tele to hani tele ma soto la bongo bar radio be bulan koto batiri sanga ay si ayala
sa do kala nyaadi
ko ta o bulaji
ado kala nyaadi
kamun ke nyaadi
radio amola be mona falaje
ibe la kandirol kala jele
ti talle be radio ko men ka karam
ila subject ro baby jele baby jele
wala nan ka coco mo fa dan so wolya ngom metambi kana ngadi ni wolje ikadum bungo ko kada marmo
ma asototal
Lamin mala be bare
bari la falal ideal on the every year second wala fourth
muna ni ko nde ko folle sinila mba ndele sinilo ne ba
say mba foke en koto wole fango yen wulindi yalo famo keta bat ñu fana bulata ko ko me yen nati jambi Lamin nyanta karana ndel beji ko be nyineka ya bulay kara wulo kono ta kilar ya bambalo yo be bulaje ko dinni ngoy si ayala le sino la moy radio
wara ka munda karamo man soro Lamin nyanta kara si so
ayala le sino
ndale ko korna kosmo
kilar ya
be ngala ko momo say mi do ni ko kera
mengi
ndale ko la da ba rosa no radio ba no bari woro radio ni abe jele ba ngam do man dembe buljan dala nyara nyar woro ko fendi mo la Lamin tayra ba rosa
ara te ku folo ajibe nori nya Lamin
mengi mun na re
teku
bari ko do famo ke
ja image nani nyambol si zol le ke kisigi man si zol no le kafun ka nyoma bari nyambu kino ni manya na kafinde ni nambe ko zol la ni nambe ko zol la
ngalle limbeta de be nyambo do dilan
nyara ni ko rin fennat nyara
bari famo ke da
ngata bungono tammi bungono nyara ngando ko fele ko ke baru nganda ni pelo la ndija
iyo a la bungono
bismillah bisu diara
pendulala ye fongo tanka sina dolu tanka koro ta koro ta
Hi everyone, I am Mr. Babukar Au, your chemistry tutor, and today we will continue our main topic, which was thermochemistry. And today our lesson will be based on standard conditions of heat change. Now, before we go into this lesson, we will try and answer our assessment together. And then the assessment questions were, number 1, the activation energy for the forward process in this reaction is A, plus 15 kilojoules, B, negative 15 kilojoules, C, positive 25 kilojoules, and D, negative 25 kilojoules. And then we have the graph. Now, if you look at the graph, you know that the activation energy is the energy between the reactants to the what? Transition state. And the energy between the reactants to the transition state is going to be 15 kilojoules per mole, because we have the reactants on our left and then we have our products on the right. And the distance between the reactants, which is on the left, to the transition state is 15 kilojoules per mole. Therefore, the correct option in this question is letter A, which is plus 15 kilojoules per mole. Question 2. The activation energy for the reverse reaction is, that is the backward reaction is. If the forward reaction is positive, which means the backward reaction is going to be negative. And then the backward reaction, by looking at this graph, we will start from the what? Products. Because the backward reaction, our products will be the reactants and the reactants will be the what? Products. So therefore, the energy needed to form the reactants again will start from the what? Products. That is down on your right to the what? Transition state. That is the end of the graph. And then the option reads A, plus 25 kilojoules, B, minus 25 kilojoules, C, plus 40 kilojoules, and D, negative 40 kilojoules. And in this case, by looking at the graph, we will add 15 kilojoules with the 25 kilojoules, so that we will have energy equivalent to the activation energy, and then the reactants will be easily formed again. And therefore, 25 with the 15, we will have 40. But as I said, the forward reaction is positive, and therefore the backward reaction must be negative. And then our correct option will be negative 40 kilojoules, and that is letter D. Number 3, what is another name for the activation? What is the other name for the activated complex? That is A, energy barrier, B, transition state, C, rate limiter, D, collision group. And the correct option in this question is transition state, which is letter B. And finally, number 4, at what stage of a reaction do atoms have the highest energy? At what stage of a reaction do atoms have high energy? Simply, this question is just asking us, what is the highest energy in a reaction? And the options are A, reactant state, B, product stage, and C, transition stage. And then the correct option in this question is letter C, which is transition stage. That is the highest energy that atoms can attain. And then we have our main topic today, which is standard conditions of heat change. Now, standard enthalpy change is the heat change that occurs when molar quantities of reactants react to form products under standard conditions. Now, for example, you have your carbon and your oxygen. You are reacting this carbon and oxygen. We know when they react properly, they will form CO2 as the product. But then this CO2 is formed under standard what? Conditions. What are these standard conditions that the CO2 is obtained? You can have one, a temperature of 298 Kelvin. That is 298 Kelvin. Two, we can have a pressure of 100 kilopascal. And three, we can have concentration of 1 mole per dm³. That's the concentration. And four, we can have standard physical states of these substances. So these are the four conditions that are standard required in the what? Heat change. And then we know that this heat change could be evolved or absorbed. And now we have types of standard enthalpy changes. Now we have many types of standard enthalpy changes, but our discussion will be based on three main standard enthalpy changes. Number one reads standard enthalpy of combustion. And this is the enthalpy change that occurs when 1 mole of a substance is completely bound in excess oxygen under standard conditions. And the standard conditions are 298 Kelvin and 100 kilopascal. The 298 Kelvin is the temperature required for this reaction to occur, and the 100 kilopascal is the pressure required for this reaction to occur. But this 298 Kelvin and the 100 kilopascal is only enough for the complete combustion of 1 mole. Note, A, standard enthalpy of combustion has the symbol. You have delta H, degree, and then you have what? Small c. And that degree there signifies the temperature, and the c will signify the combustion. And B, accurate determination of standard enthalpy of combustion of a substance is carried out using a Bohm calorimeter. And in our previous class, we saw the diagram of this Bohm calorimeter. That calorimeter is the main calorimetric apparatus used to measure standard enthalpy of combustion. C, the standard enthalpy of combustion is always negative. It's always negative, which means this is always what? Exothermic reaction. Combustion of any substance will be negative because, one, the reaction is exothermic and heat is lost to the surrounding, which means when combustion is taking place, the energy processed by the reactants is so high that they need to release some energy to the surrounding so that the energy will be equal to the activation energy and the products will be easily formed. And two, the energy needed to break the bonds is always less than the one liberated when the bonds are formed, which means the energy possessed by the reactant is always more than the energy possessed by the products. Now, with these two reasons, standard enthalpy of combustion is always negative. Now we have determination of enthalpy of combustion. And then we have the following steps. If we perform, or if we try to follow these following steps, we'll be able to determine the enthalpy of combustion of any substance that we want to find. The first step is, as Roman figure 1, you put some ethanol in a bottle. Because you know that you can combust ethanol, you can burn ethanol in excess oxygen. You have to put ethanol in a bottle, and 2, make a hole in the cover of the bottle to insert a wick. This wick now is a small thread that you combust, and then it will lead to the burning of the ethanol itself. But then you insert this wick at a hole in the cover. 3, weigh the bottle and its contents. That you weigh the bottle and also the what? The content of the bottle. And the content of the bottle will be the what? Ethanol, including that small wick that you have inserted. Roman figure 4, put about 100 cm cube of water into a beaker and record its initial temperature. Now this initial temperature will be the temperature before the reaction. And 5, light the wick and hit the beaker directly and record its final temperature. You light the wick, and when the wick is lighted, it will lead to the burning of the ethanol. And then the beaker also is what? Is heated. Now after this, you record its final what? Temperature. After recording the final temperature, after the burning has taken place, you extinguish the flame and weigh the bottle and its content again. That is, you stop the fire and weigh the bottle and its content. And the content will be still what? Ethanol and also that wick. But the first mass that you weigh and this final one will not be the same, because some of the ethanol has burnt. And then the final step is the loss in mass is the mass of the ethanol burnt. That is, the difference between the initial and the final mass will be the mass of the ethanol burnt. And now here we have specimen results. And these results were obtained from a standard experiment. And then we have initial temperature of water, which is equals to 24.6 degrees Celsius, which is equal to 297.6 Kelvin. That is, if you want to convert degrees Celsius to Kelvin, you add 273 to the degrees Celsius. And when you do that, you will have 297.6 Kelvin. Final temperature of the water is equals to 49.4 degrees Celsius. And this temperature is obtained after burning. And 49.4 degrees Celsius is equals to 322.4 Kelvin. Mass of water in the beaker is equals to 100 grams. We know that the water in the beaker is measured in volumes, but then 1 cm cube is equals to 1 gram. Therefore, 100 cm cube will still be equal to 100 grams. Mass of the bottle plus ethanol before burning. That is, the mass of the bottle including the ethanol before burning is equals to 32.05 grams. And again, mass of the bottle plus ethanol after burning is equals to 31.65 grams. Mass of the ethanol bond is equals to 32.05 minus 31.65, which is equals to 0.4 grams. And this 0.4 grams is the mass bond. And then the molar mass of ethanol is given in the results, which is equals to 46 gram per mole. And the formula of ethanol is C2H5OH. And then the specific heat capacity of water is given, which is equals to 4.2 joules per gram per Kelvin. And then when calculating the standard enthalpy of combustion, we work by the clue given. And the clue given here is the specific heat capacity of the water. And the energy there is in joules. And the mass also is in grams. And the temperature also is in Kelvin. Which means we cannot work with degrees Celsius in this case, or we should not convert the mass to moles, because the unit of the specific heat capacity given is joules per gram per Kelvin. And now we have our calculation. And now we have our calculations using the displacement results. Now, the mass of water is equals to 100 gram, which is already given in the displacement results. Now we need to calculate the what? Rise in temperature. And rise in temperature can be obtained. We have rise in temperature can be obtained when we have T2 minus what? T1. That is T2 minus T1. That is the final temperature minus the what? Initial temperature. And our final temperature was 322.4 minus 297.6. And now here we have 322.4 minus 297.6. And then I'll use the calculator and point. 322.4 minus 297.6. And here I have something like 24.8. And this 24.8 is in what? Kelvin, because both these values are in Kelvin. Now, after knowing the rise in temperature, I'll calculate what? The heat what? The heat evolved. The heat evolved. And the heat evolved is calculated from the formula mc theta. And this m is for mass of the water used, and this c is the specific heat capacity of the water, and then this theta is the what? Rise in temperature. We are calculating the heat evolved using the information from the water, because water is used as the absorbent material in this case. And the mass of water given in the displacement results is 100 grams. We multiply it by 4.2, which is the specific capacity of water, times change in temperature, or what? Rise in temperature, which equals to 24.8. 24.8. Again, I will say 100 times 4.2 times 24.8. And then I will have 1041 6. And the unit here is what? Joules, because I'm calculating what? Heat evolved, joules. So this is the amount of energy possessed by the what? Water. That is the heat evolved in this reaction, or the heat evolved by the absorbed materials is 10,416 joules. And then if you want, you can divide it by 1000, so that you will have what? Kilojoules. Now, we need to calculate the amount or the standard enthalpy of combustion of ethanol. Because we say the standard conditions, one of them is what? 1 mole. And this is not the energy evolved by what? 1 mole. This energy was evolved by what? 0.4 grams of the ethanol. That the ethanol that has burned is the amount that produced these 10,416 joules. Now we can simply calculate the standard enthalpy of combustion of ethanol by saying if 0.4 grams of ethanol, which is C2H5OH, produces 10416 joules. That is therefore 46 grams of the ethanol, which is C2H5OH. I'm using 46 grams because 1 mole of ethanol is equals to what? 46 grams. You can verify this when we have C2H5OH. When you are given the respective relative atomic masses, carbon will be 12, and then you will have 12 times 2 plus hydrogen is 1 times 5, because we have 5 atoms of hydrogen, plus oxygen is 16 times 1 plus 1 times 1 for the hydrogen atoms. And if you add this, and this, you will end up having what? 46 grams per mole. This is the unit of molar mass, which is gram per mole. And this unit means in every single mole of ethanol, you have 46 grams. That is, every single mole of ethanol possesses what? 46 grams. The same as if you say the molar mass of sodium is 23 grams per mole. This means every single mole of sodium constitutes of what? 23 grams. The same thing applies in this case. That is, 1 mole of ethanol possesses 46 what? Grams. Now we will say 1 mole of ethanol equals to what? 46 grams of ethanol will give us what? X joules. We cross multiply. And in this case, we will have 46 times 10416 divided by 0.4. Again, I will use the calculator and say 10416 times 46 divided by 0.4. I will have 119,784 and then I will have what? Joules. This value now is a large value. I can reduce it by divided by what? 1000. So that I will have what? The energy in what? In kilojoules. Now, if you divide this, you will just have here 1, 2, 3, and then I will have 11,978 kilojoules. So this is the amount of energy evolved by what? 1 mole of ethanol, and 1 mole of ethanol equals to 46 grams. We maintain the gram because the specific capacity of the water given is in joules per gram per Kelvin. And now we know that standard enthalpy of combustion is always negative, and then we include our what? Our negative value. So at the end, this is our answer. And on the screen there, you have the same thing. That is, if 0.4 grams of ethanol, which is C2H5OH, gives you 10416 16 joules of heat. Therefore, 46 grams of ethanol, which is again C2H5OH, will give you X joules of heat. You cross multiply, and then the answer we have is 11,97840 joules. Hence, the heat of combustion of ethanol is minus 1198, which is minus 1,198 kilojoules per mole. See, you can reduce the value by dividing with 1,000, and then you will have your energy in kilojoules. Now, with this, we come to our assessment, and the assessment question reads: the following results were obtained from an experiment to determine the standard enthalpy of combustion of ethanol. And then the initial temperature of water given is 25.5 degrees Celsius. Final temperature of the water given is 50.0 degrees Celsius. Mass of water in the can is equals to 200 grams. And the mass of ethanol bond is equals to 1.0 grams. In this case, you are already given the amount of ethanol bond. No need to struggle and find the mass before burning and the mass after burning. The amount of heat produced by using ethanol to burn the wick is the same as the heat that raised the temperature of 200 grams of water of specific heat capacity of 4.2 joules per grams per Kelvin from 25.5 degrees Celsius to 50.0 degrees Celsius. Now calculate the standard enthalpy of combustion of ethanol. Calculate the standard enthalpy of combustion of ethanol. And that was everything about the assignment. So just try and follow the previous steps that we did to answer the first question, and then try by all means to answer this assessment question. So we'll try and solve this problem together when we meet in our next lessons. So stay tuned for more educational videos. Thank you all.